morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about definition and terminology on Introduction to Image Processing. So first one, what is image? Define digital image. So an image is a 2D or 3D signal that can be observed by human visual system. And digital image, representation of image by sampling in time and space. Digital image processing perform digital signal processing operations on digital images. And the field of digital image processing refers to processing of digital images by means of a digital computer or set of computer algorithms. So, what is the image? What is the digital image? And what is the digital image processing? Digital image processing. So, suppose I'm taking any of the image. Suppose I'm taking one image. That image I'm taking as a pixels. It is a 3 by 3, means 9 pixels are there, 9 cells are there. Okay, so I'm taking as a coordinates of x and y. So, what is an image? Suppose one person is there. I'm capturing this person through a camera or sensor. Okay, so it is an object. So, before capturing this person, it is the analog. After capturing, it is a digital image. So, an image is a 2D or 3D signal that can be observed by human visual system. And digital image representation of image by sampling in time and space. And digital image processing perform digital signal processing operations on digital images. The field of digital image processing refers to processing of digital images by means of a digital computer or set of computer algorithms. Image processing is a method to perform some operations on an image in order to get an enhanced image or to extract some useful information from it. It is a type of signal processing in which input is an image and output may be an image or characteristics of features associated with that image. And the main objective of image processing is to transform an image into digital form and perform certain operations on it in order to obtain specific models or to extract useful information from it image. So I'm taking one image. This image I'm taking as a 3 by 3 size. That means 3 rows and 3 columns. So this image is a method to perform some operations on an image in order to get an enhanced image or to extract some useful information from it. And it is a type of signal processing in which input is an image. So I'm taking as an input is an image and output may be an image or characteristic features or output an image. But it is an analog image, input is analog, output is a digital image or characteristics features associated with an image. So the main objective of image processing is to transform an image into digital form and perform certain operations on it in order to obtain specific models or to extract useful information on that image. So any of the image, I'm taking one object. It is one object. So the main object of image processing is to transform an image into digital form. So this is conforming into the digital form. So and perform certain operations on it. So certain operations means suppose I have an image that is a noisy. So how can I reduce? We are using some filters. And in order to obtain specific models or to extract useful information from the image. So any of the image, I'm taking one object. This object I'm calling as an analog. When I'm converting into the digital, it is a digital image. It is a digital image. So what are the advantages means? Suppose it is a noisy. So reduce noise using filters. Or suppose this digital image, I have to color image. So gray image to color image, or color image to gray image. So noisy to reduce the noise, or reduce the noise to noise image, anything. We are using some filters technique. Okay, any of the objective. So we are the image processing to transform an image to perform operations on it to obtain specific models or extract useful information from that image. Okay, so there are certain operations to perform on the objective of the image to transform of one transform to another. One transform to another means gray level of image to the color image to the gray level, like this. So define 2D and 3D images. What are the 2D and 3D images? Some example I am taking, it is one object. I am taking as a coordinates as x-axis and y-axis. So an image is a two-dimensional. That why we also define an image as a two-dimensional signal. An image has a only height and width. An image does not have depth. Just to have a look at this image. So this image I am taking has a, what is the width? This width I am taking as a x, and what is the height? This I am taking as a y. So I am taking x and y. X equal to width and y equal to height. X equal to width and y equal to height. So any of the image, what is the width of this image and what is the height of this image? We have to find out. So width how much, height how much. So we are using some coordinates and we are finding out. So it is a two-dimensional. We have to find out the two measurements, that is a width or height, like this example. And we have already seen that in the two-dimensional signal, that is a f of x comma y. If any of the image I am taking as a x and y, two-dimensional, 2D. So that is I am taking as a f of x comma y. So this f of x comma y I am calling as a image. So we have already seen that the image is a two-dimensional and have the mathematical representing f of x comma y equal to image, where and x, y are the two variables. The concept of two dimension can also be explained in terms of mathematics. Okay, so I'm taking as a two-dimensional in terms of mathematical. What is the equation in the 2D? That is a f of x comma y. That is a in terms of image. And three-dimensional signal. Three-dimensional signal, as its names refers to those signals which has three dimensions. Another example of a three-dimensional signal is a cube or volumetric data, or the most common example would be animated or 3D characteristic. And if I'm taking the x, y and z, okay, it is a 3D animation. 3D, three coordinates are there. So the three dimension is a names refer to those signals which has a three dimensions, and it is an example of three dimension means cubic, volumetric data, or most common example is a animated or 3D coordinate characteristics are the 3D. And the mathematical representation of the 3D is a f of x, y, z is equal to image or animated image. So the mathematical representation of the three-dimensional is f of x, y, z equal to animated character. Another axis of dimension z is involved in a three-dimension that gives an illustration of depth in a certain coordinate system. It can be viewed as x, y, z. X, y, z. Three coordinates are there. That is a f of x, y, z equal to three dimension. F of x, y, z equal to image or animated image. Okay, I'm taking this example as a graph. So what is this one? X and y, and what is the z transform? Okay, like this. So three dimensions are there. And what is the 4 adjacency and 8 adjacency and n adjacency? Suppose I'm taking what is 4 adjacency, 8 or n adjacency. That is the nd of p and n8 of p. So 8 means 8 adjacency. Nd equal to d adjacency. The 4 diagonal neighbors of p. The 4 diagonal neighbors of p have coordinates x plus 1, y plus 1, comma x plus 1, comma y minus 1, x minus 1, y plus 1, x minus 1, y minus 1. How many are there? 1, 2, 3, 4, and denoted by nd of 4. So how many are there? These are the 4 coordinates. So that is called 4 adjacency. So what are the 4 adjacency means? x plus 1 comma y plus 1, x plus 1 comma y minus 1, x minus so total 1, 2, 3 and 4. So it is a 4 adjacencies there. So these are the 4 adjacency, that is a 4 diagonal neighbors of P have the coordinates. And if I am going for the 8 adjacency, these points together, 4 adjacencies are called the 8 neighbors of P, denoted by N8 of P. So when I am taking the 8 adjacency, that is called 8 neighbor. So we consider the 3 types of adjacencies. There is a 4, 8 and n adjacency. First one I am taking the 4 adjacency. 2 pixels P and Q with values of from V 4 adjacency Q in the set of N4 of P. So that is I am taking as a P comma Q, f of P comma Q. So how many probabilities are there? 2 square means 4. So 2 objects are there. Two objects are there. 2 variables are there. 2 square equal to 4. So that is a 4 adjacency. If I am taking the x, y, z, if I am taking x, y, z, f of x comma z, how many are there variables? 3 variables means 2q equal to 8 adjacency, like this. So 2 pixels of P and Q, that is I am taking as a 4 adjacency. If I am taking the 8 adjacency, 2 pixels of P and Q with the values of V, that is a 8 adjacency of Q. So M adjacency is mixed with M adjacencies M. So 2 pixels P and Q with the values of V and M adjacency. Q is in the N4 of P. Q is the ND of P. N4 of P means 4. ND of P means number of adjacencies, that is ND of P. And if I'm going for the different adjacencies with one dimensional, so what will happen in the one dimensional signal means the common example of one dimensional signal is a waveform. It can be a mathematical representation of f of x. F of x means only one dimension, 1D. And where x is an independent variable, since it is a one dimension signal, so that why there is only one variable is x is used. So in the different are called what is 1D. What is 1D? So it is like this. So 1D is a one dimensional, that is f of x equal to waveform, x equal to one variable, and x is an independent variable, one dimensional signal, that is a variable of x is used. So what are the applications of digital image processing? Image sharpening. First of all, application is image sharpening and restoration. Image sharpening and restoration. Second one is a medical imaging. Third one is a surveillance. Fourth, law enforcement. Fifth one is artistic effect. Sixth is a machine or robot vision. Sixth, color processing. Seventh is a video processing. These are some examples, and some more examples etc. are there. So sample I am taking 7 examples. So what are the applications in digital image processing is the image sharpening and restoration. That is first one, image, and the second one is a medical imaging. Third one is surveillance, law enforcement, artistic effects, machine robot vision, color processing, and video processing. We are taking some examples with images proof for the applications. First one I am taking as a most common use of digital image processing technique is improve quality and remove the noise. So here it is the input original image. Actually it is one X-ray, but we are not getting any information this one. Why? Because it is a noisy, means some black is dominating. So I have to remove some, how much dominating the black I have to remove. That is removing the noise. That is reduce black. So that is a reduce black. It is the output image with X-ray is the identifying image. Here also input image is there. It is dominating. It is a GPS or GPRS image is there from satellite. So it is a satellite image. So it is dominating some white color. I have to reduce this one. So it is the output image or noisy. Output image noiseless. That is remove white. Okay, so improving the quality and removing the noise, that is the important thing of any of the image. So removing noise is means obviously it is identifying image, and improving the quality of the image also important role. And it is the artistic effect are used to make an image more visually appealing, to add special effects and make composite images. Okay, it is mostly we are using as a 3D image. So 3D images, it is like when he is moving, or it is like artistic work. Most artistic works are the 3D or animating. So artistic effects are there, and it is a medical images means X-rays, like this. Artistic work means 3D effect. So it is some one input image. So what is happening means here, it slice from MRI, magnetic MRI, magnetic resonance image scan of a heart, and find the boundaries between types of tissue. Image with gray levels representation tissue density. Use a suitable filter to highlight the edges. Okay, so we are, what is that means? So we are highlighting the edges at output, and the gray levels are representing as a tissue density. So what are the borders are there? We are highlighting these margins. What are that means? We are highlighting with white. So white is highlighting. So it is a one sample MRI scan. We are converting to the highlighting the important segmentation with the gray level representation tissue, and it is a suitable filter is highlighting the edges. We are using for some filter from smoothing and sharpening of the edges. Image sharpening and restoration. Sharpening means smoothing and sharpening in filter process. So we are using smoothing and sharpening. So the heart of boundaries between types of issue, image gray level representing tissue density, suitable filter to highlight. Suitable filter means we are using some smoothing or sharpening. So it is another image, say 1, 2, 3, 4, 5, 6 like this are there. So it is a geographical information system of the input images. At the output, what is happening is digital image processing technique are used extensively to manipulate satellite imagery and the terrain classification and meteorology. Okay. So when I'm using the GPS or GPRS or satellite or geographical information system, we have to convert into the identifying image. Okay, so some white is dominating, we have to reduce the white. Black is dominating, and we have to go for the smoothing and sharpening technique. Okay, all are we have to use, we have to done with the geographical information system. So the digital image processing DIP techniques are used extensively to manipulate satellite imagery and the terrain classification and meteorology purposes. And it is one example of image processing technique are used extensively by law enforcers. Number plate recognition for speed cameras, automated toll system, fingerprint recognition. Okay, suppose it is identifying, it is a identifying image. Okay, it is an unidentifying image. So unidentifying is converting to the identifying image. So here using some thumb or fingerprint. It is the unidentified is converting to the some identifying pixels using some filters. Okay. So number plate recognition, speed cameras, automated toll systems, and fingerprint recognition. Okay. Here the input is there. Some noisy is there. Noisy input. So at the output side, we are converting. So black is dominating. We are reducing the black from this one, and we are highlighting like this. Okay. These are the examples of image processing applications. It is especially for law enforcement. And another one is a HCI. So try to make human computer interface. Human computer interface. So in the human computer interfaces, more natural face recognition, gesture recognition, and these are the important. In the figure, we can observe. Suppose I have to highlight the face, hands. These are the face. So face recognition, object recognition are the major important role of human computer interfaces (HCI). So to make human computer interfaces for more natural, face recognition and gesture recognition. Face recognition and gesture recognitions are the important. Gestures means what they are doing. Suppose smiley or serious, or suppose his face is serious. Suppose some faces are smiley. So gesture means we are identifying what is the posture of the image. So smile image or whatever may be. So we are gestures or we are identifying the gestures or postures of that one. That is a face recognition and gesture recognition. And does anyone remember that user interface from Minority Report? These tasks can be extremely difficult in that. And we are using in the computer graphics also the set of images, and image processing is using for enhancement of other manipulation of images and the computer vision analysis of the image content. So computer graphics is nothing but a 3D, and computer vision is the analysis of the image, and image processing is the enhancement or manipulation of the image. And the field of digital image refers to processing of digital image by means of digital computer. Suppose I'm taking f of x comma y, so that is a 2D two-dimensional image, and x and y are the spatial plane coordinates, and amplitude of f at any pair of coordinates, that is x comma y, is called the intensity or gray level of the image. When x and y are the amplitude values, amplitude or finite discrete components of the image digital image processing. So it is the amplitude, and it is what is your requirement height or whatever may be. Okay. So these are something for image may be defined as a two-dimensional function of f of x comma y, and x comma y are the spatial coordinates with the plane, and x comma y are called the intensity or gray level. So what is the intensity? So this one, intensity or gray level of this one, and image at point x comma y are the amplitude values also finding, and frequency also we are finding with this one, and finite discrete quantities we can call of image in the digital image. And what are the components of image processing? Okay, so in the question they are asked what are the components or need in image processing, in image processing system. So it is one question, and the answer is what are the components we need for image processing is a image display, computer, mass storage, hard copy, and specialized image processing hardware, image processing software, and image sensors. So these are the issues and whether the components are needed for the basic image processing system. And it is nothing but a typical general purpose tip system, typical general purpose digital image processing system. Okay, so it is under network. So first one, image display. Image display means it is showing as a analog or digital, it will be display. Okay, image display where I need Display is computer. In the computer only, the image should be displayed. Okay, when you have to show the image, computer is needed to display, and I have to store the restoration process, mass storage for the image story or restoration. So memory is saving in a mass storage, and specialized image processing hardware. So we need one hardware to specialized image processing to reduce the noises or to have to any modifications or any of the image original. We need some specialized image processing hardware. Need some cameras or some sensors or whatever may be. So I need some camera. It is connected to some computer. Suppose my images are in pen drive or any hard disk. Okay, hard disk, mass storage, it will be connected to this one, and it is a image processing software. Image processing software means it is some MATLAB or Photoshop or any software I need to display the image. And image sensor is nothing but in the our language it is a camera. Image sensor is nothing but a camera. Problem domain means suppose one image is there in the camera. I was captured this object. I was captured through the image sensor. So in the image sensor, it is a hardware I need to capture this one. And if I need a hard copy, then I will go to computer and it is going to the print hard copy. If I want to show the image, it will be showing image display. If I want to store this one, image store, and it is a image software. So suppose I have to capture this image. That is a image sensor I need. So image sensor is captured this image. After then what I need a computer to display, or I need to store this one, storage, or I need to print this one, that is a hard copy. I need a software to any modifications I need to done. I need a software. So image is a camera object, specialized image processing, and I have to go for the hard copy means then I will open in a computer and I will go for the hard copy. That means a print of the copy. If I want to show the image, what is the size and how looking is the object, that is going as the image display. If I want to store in any of the device or any of the hardware devices, mass storage or any pen drives or anything, mass storage is needed. Image processing software is if I want to do any modifications. That means gray level to color to gray, or noisy to reduce the noise. If I want to use any filters, so I need image processing software I need for the modifications of the original image. And what is image sensors? There are two elements are required to acquisition of the digital images. So what is sensor? Sensor is nothing but it is like a camera. It is a hardware. The first is a physical device. Okay, it is a physical device. In our language, it is calling as a camera to capture the image, to capture the object, That is the analog form. Okay, this I am converting to the digital. That is called image. So in the analog form, it is an object. After capturing this one, it is a digital. That is the image. So what is sensor? Sensor is a physical device to sensitivity or sensitive to the energy radiated by the object we wish to image. So energy radiated from the object, to we are carrying something. So that is the we wish to image sensors. And the second is called the digitizer. Is a device for converting the output of the physical sensing device into the digital form. So digitizer means analog is converting to the digital. So what is the analog here? It is an object. So this object I am converting to the digital image. So this I am calling as a digitizer. So the second is a digitizer, if converting from output of the physical sensing device into the digital form. Okay, suppose It is the object, that is the analog. So I have to convert into the image, that is the digital. So analog is converting into the digital, A to D conversion. So A to D conversion is nothing but a analog image is converting into the digital image through the digital image. So it is the second of digitizer. So it is the entire process is nothing but a digitizer, is a device for converting the output of the physical sensing device into digital form. And what is a specialized image processing hardware? So what is the hardware I need after capturing the image from the sensor? What I need? What is the next step? That is the image processing hardware. It is consist of digitizer. Digitizer means after the output of the image through sensors. It is mentioned before plus hardware that performs other primitive operations such as an arithmetic logic unit which performs arithmetic and logic operations in parallel or entire images. Okay, so I want to do any modifications, digital, analog to digital or A to D conversion. And this type of hardware sometimes is called a front-end subsystem and is most distinguished characteristics in speed. In other words, it is a unit performance functions that require fast data throughputs that are the typical main computer cannot handle. Okay, so what is the image processing hardware? It is consisting of digitizer. Already we discussed here. The second is a digitizer. Primary is the physical device. Second one is a digitizer. It is mentioned before the hardware that performs other primitive operations such as an arithmetic logic unit which performs arithmetic and logic operations in parallel. Okay, so that is a analog to digital conversions or any of hardware sometimes is called a front end subsystem and is most distinguished characteristics is speed. Other words, this is unit to perform functions that require fast data throughput that as a typical main computer cannot be handled. So another is the image processing software. What is the software I need? Means software is complete but nothing but it is a digital image. The image in the form of digital. The image in the form of digital. Software for image processing consists of specialized modules that perform specific tasks. A well-designed package also includes the capability for user to write code that is a maximum or utilizing the specialized modules. Okay, software to do modifications or to reduce size or noises, whatever it may be. So image processing software is consisting of specialized modules that perform specific tasks. A well-designed package also includes the capability for the user to write code that is a minimum and utilizing the specialized modules. And the mass storage is important. So mass storage is nothing but to store the image in a device. To store the image in the device. Okay, what is an image? Digital image. So digital image only possible to store in the mass storage. Mass storage is nothing but any of the memory. So mass storage capabilities is a must in image processing applications. Image of size 1024 into 1024 pixels are required. 1 megabyte of storage space if the image is not compressed. So suppose I have to store 1024 megabyte storage space in the image is not compressed. Okay, so the image is there, we are not compressed, but the size is very high. Okay, big size of image is there, I have to compress. So digital storage of the image processing applications falls into three principal categories: short-term storage, online storage, archival storage, or characteristic of infrequent access. So there are three types of mass storage capabilities are there. Short-term storage, that is means during the process, it is a temporary. So when we are capturing, suppose one object is there in the camera or in the sensor, it is showing, the object is showing in my sensor. That is a temporary purpose. That is a short term. After capturing, after getting the digital image, definitely we need a storage to store that one. Okay, that is a temporary storage. Online storage means I don't need of any hard disk or any hardware of my computer or any memory card like this. Okay, online system in the web page I have to store. And archival storage characterized by infrequent access means a permanent storage of the memory or mass storage. And the mass storage capabilities of providing short-term storage is a computer memory. Another is by specialist boards called frame buffers that store one or more images and can be accessed rapidly. Online storage method allows virtually instantaneous image zoom as well as scroll, vertical shift, and pan, horizontal shift. Online storage generally takes the form of magnetic disk and optical media storage. And the key factor of the characterizing of online storage is the frequent access to the stored data. And finally, archival storage is characterized by massive storage requirement for infrequent need of access. So, first one is a short-term storage. So, it is providing a short-term storage in computer memory. Another is by specialized boards called frame buffers that store one or more images and can be accessed rapidly. It is a one type. And another one is a online. Online means I don't need of any hard disk hardware. Okay, it is some big data computing or anything online system. Okay, no need of any hard disk I need. So it allows virtually instantaneous image zoom as well as scrolling or vertical shifting or horizontal shifting. Online storage generally takes the form of magnetic disk and optical media storage. The key factor of generating optical or online storage is frequent access to the stored data. Okay, I need some login details of software or any website like this. And finally, archiving storage is characterized by massive storage requirement, but infrequent need of accessing. Okay, infrequent means permanent. Frequently, I'm not using. Okay, that is I need a permanent. I need a permanent storage. Short-term storage, online storage, short-term storage, online storage, and hard disk. That means mass storage. That is the storage of this one. So I need permanently. Okay, it is the web based with security. So these are the three types of memory. So image display, where it is will display, it is a TV monitor or computer monitor or any camera or any mobile phones like this. So the display in use today are mainly color, preferably flat screen TV monitors. Monitors are driven by the outputs of the image and the graphics display cards that are an integral part of a computer system. And hard copy devices. Hard copy is nothing but a it is a print like print film camera used for recording images, included laser printer, film camera, heat sensitive devices, and inkjet units and digital unit such as optical and CD-ROM. Okay, so image display means TV monitor, computer screen, and display card. So mainly color, preferably flat screen. Okay, these are all in color as possible, color or black and white or gray. So TV monitors are driven by the outputs of the image and the graphic display cards, and the hard copy devices used for recording images, including laser printer, film camera, heat sensitive devices, inkjet units, and digital units such as optical and CD-ROM disk. These are the hard copy devices. And what is a networking? It is important role for the image processing system, is almost a default function in any computer system in use today because of the large amount of data inherent in image processing applications. The key consideration of image transmission is bandwidth, and dedicated networks of typical is not problem, but communication with remote sites via the internet are not always of efficient. Any of the internet or websites or large amount of data we need, the networking is important role. And it is a fundamental steps of image processing. First one is a color image processing, wavelet multi-resolution, image compression, morphological process, segmentation, object recognition, representation description, image acquisition, image enhancement, and image restoration. So these are the fundamental steps in image processing. It is the image acquisition. So image acquisition. So image acquisition means, suppose I have the element. Image acquisition means, suppose I have an object. This object I am converting to the pixels. Object to the pixels. And image acquisition, the modalities of getting the image into the computer. Image is captured by a sensor or camera, so it is captured from object to pixels. And step 2, image enhancement. It is the input image. It is unidentified, where output is a identified image. And image restoration. Suppose it is input image, so I have some modifications are done. I've done some modifications. So output with restoration. And next one is a morphological process. Means some blur, some noisy is there. Reduce the noise. So noise is converting to the reducing the noise. And the segmentation means, suppose it is one image object, it is another object. This object is a one segment. So the object is converting into the segments, means different objects. And it is the object recognition. So what is a vehicle? This one, is it vehicle or not? What is this one? It is a car, and it is a bus, and it is some van. So we are recognizing the vehicles, or capturing the faces, or hand, gloves, legs, and capturing of image like this. And representation of description. So how we are representing the description? Okay, region based boundary representation means 2-dimensional, 3-dimensional, or like this. Okay, we are segmenting. And image compression. Okay, compression means I am reducing the size. Reducing the size. Okay, it is a compression. We are using some software to compress this one. Okay, and the color image processing. It is converting input image as no color, added colors. That means red, blue, green, RGB, red, green, blue, like this. So another one is a multi-resolution analysis using wavelets. So how we are multi-resolution? Multi-resolution means it is a foundation of representation images in various degrees of resolution, and it is used for image data compression, where images are subdividing into smaller regions. And the multi-resolution analysis is a different approach of signal processing, and that gives a well as detailed information at the same time. And it is the MRA resolution of signals, and wavelet transform gives more information than Fourier transform. Fourier transform and wavelet transforms are the resolutions, or multi-resolutions, or converting from one image to the another image. Image conversion. So it is a multi-resolution analysis, and it is a color image processing, image compressions, representation of description, object recognition, and image segmentation, morphological processing, image restoration, image enhancement, image acquisition. So these are the major fundamental steps in digital image processing. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.